Today we'll talk about exponential functions. Exponential functions are functions of the form f of x equals a to the power of x, where a is a number and this number has to be greater than 0 and it has to be not equal to 1. There are two different kinds of exponential functions. One is where a is anything between 0 and 1. So it can be anything like 1/2 or 3/4 or 0.7, so anything in between 0 and 1. And the second kind is where a is greater than 1, so those a's are 1.5, 7/3, 2 or 3, etc. So an example of the first kind of an exponential function is f of x equals, let's say, 1/2 to the power of x. So we just look back at this formula, a to the power of x, and my a here is 1/2, so it falls under this criteria where a is in between 0 and 1. And an example of the second kind where a is greater than 1, let's say g of x, that is equal to 2 to the power of x. So here your a is 2. In the case of the first kind, where a is between 0 and 1, the function will be decreasing. In the case of the second kind, where a is greater than 1, the function is increasing. The domain of both of these kinds of exponential function never changes, and it's always from negative infinity to infinity. The range is from 0 to infinity unless there is a vertical shift. So what I'm going to show you next is how to graph both of these functions that I have as examples. So here we have our two functions. To graph them, I'm going to just say that my first x will be 0. So that means I am finding f of 0, meaning it's 1/2 to the power of 0. Well, 1/2 to the power of 0 is 1. Anything, in fact, to the power of 0 is 1. So what this means is when I selected the x to be 0, the y for that x was 1. So my first point is 0, 1, and it's right here. The next x that I will select is, let's say, a positive 1, which means I'm finding f of positive 1, or it's 1/2 to the power of 1, and 1/2 to the power of 1 is itself, it's 1/2. What this means is that when x is 1, y is 1/2. Well, with some software it may be difficult to graph half of a unit, so I'm going to pick a different x, plug that x in, and then see what I get. Maybe I can have a whole number instead of a fraction. So let's select a negative 1 for the x. That means I'm finding f of negative 1, which is 1/2 to the power of negative 1. Now, what does a power of negative 1 do to a number? It flips it. It does not make it negative. So instead of 1/2 to the power of negative 1, I will have 2 over 1 to the power of positive 1, which is just a 2. So the third point that I have is negative 1 for the x and 2 for the y. So here we go, we're connecting them. Make sure you do not cross the x-axis, because the x-axis for this function here is the asymptote. So y equals 0 is the asymptote. We'll do the same to graph the g of x, that is equal to 2 to the power of x. So again, I'll select x equals 0, just like I did with the f of x, which means I'm looking for g of 0, and that's 2 to the power of 0. Anything to the power of 0 is 1. So my first point is 0 for x and 1 for y. And notice I had the exact same point in the function f, and that's because anything to the power of 0 is 1. So it's like a magic point that the exponential function will go through that 0, 1. And I'm going to select something else, let's say positive 1. If x is positive 1, then I'm looking for g of 1, and that is 2 to the power of 1, which is 2. So the second point has the x of positive 1 and the y of 2, and that is right here. And these points are nice, you don't really need the third one. If you want another one, you're welcome to select something else. I'm going to do it just for the purposes of demonstration. Let's say we select a positive 2. So then I calculate g of positive 2, and that means my positive 2, and the exponent is now 2, so that's a 4. So when x is 2, my y is 4, and that's the point right here. And we connect the 3 points that I have. Again, please do not cross the x-axis, because that is the asymptote. The equation of it is y equals 0.